Am I audible? Hello. Hello. Okay. Hello students, today we will do types of functions. So there are basically different types of functions in terms of their categories, right? There are different types of functions in like there, you can say quadratic functions, polynomial functions. So those are different types of functions. But when we try to understand which type of functions are they, in what category they will form. So there is injective, subjective, surjective types of functions. So first we will see what is our injective function. That is also called one-to-one function. Okay. So in the last class we saw that what is a function. Function is a rule that is set with the set A to the set B, right? So here, if function you have given a ruling or mapping from A to B is injective or one-to-one, when you will say they are one-to-one, if different inputs map to different outputs. So whatever the input you will put, there will be always one element in their output. So no two elements in A map to the same elements in the B, right? Like here, if you will see, we have a set A and set B. So in the set A, we have 1, 2, 3, right? And the B set is 4, 5, 6. When we are putting that as an input, what we are getting as an output? We are getting as an output 4, right? Okay. Then we are putting input as a 2, we are getting output as a 5. Okay. And when we are putting 3 as output, we are getting. So what you are observing here, each input maps to a unique output, right? And no two elements of A like 1 or 2 have the same element here 4. Okay, so this was not the condition. So you can say a function injective or one-to-one if each element of a set A that is associating with a function to B, right, with B. So there is always a unique association. Okay, that is the injective. Now the second one is our surjective functions. A function f A map with the B, A associate with the B, is surjective if every element of B is an output of f. So you can say here, for all the B that is belonging to the set B, exist A that belongs to A, set A, such that fa equals to fb, right? Should be the element of B, right? Okay, so see here, what is saying that here suppose we have a set A and here we have a set B. 1, 2, 3 is our element in the set A. 4 and 5 are the elements in the set B. So it is related with the function f. Function is a rule. So there may be quadratic rule, there may be polynomial rule, cubic rule, trigonometric rules that associating the element A and B, means input and output. So one is associating when we are putting here f1. What is our output? 4. Suppose we are getting 4. So 1 is associated with 4, right? When we are putting 2, we are getting 5. Okay, no problem. We are getting 5. But when we are putting again the 3, we are getting 5 as an output. So what you are observing, just 2 and 3 are giving the same element. Okay. No, 4 here. Yeah, 4 even. That's not problem. Even in example 4 is there. Our purpose is here to show you that they both are associating with the same element. So it's not strictly saying it should be the unique element for all the A. It may be the similar output for the two different input. Okay. So main purpose is here to see that how it's saying that if every element of B is an output of F, right? So what it's coming in the mind that, okay, if all the elements of B is associating with the A, so B is our, what is B? Codomain. So you can say that when the codomain becomes equal to the range. Yeah, see, it's also saying the range of f equals to the codomain. So in the previous one-to-one injective function, suppose there is element 7, maybe in the element 7, but it's not necessary for the A to associate with all the elements, right? They must associate only to the unique element. But when we are talking about the surjective or one-to function, right, our element should be associate with the same elements, like element of A can associate with the same element of B, okay, but all the elements of B must be mapped with the pre-image A. So this is our image, I told you, and this is our pre-image. So for all the image there is a pre-image, okay, in on-to functions, because every element of 4, 5 is an output of F. Now the bijective. So bijective is interesting because this is the bijective. You can see that bi means it's the combination of both injective and the surjective. So function A to B is bijective if it's both injective and surjective. This means each element in A maps to a unique element in B. So every element in B is mapped to exactly one element in A, and as well as their range need to be the equals to the codomain, right? When we will see the individually in injective function, it's not necessary for the domain to be associated with all the elements of codomain, right? Means range should not be equals to the codomain. But in the surjective, what we saw, that they should equals to the range and codomain should be equal. Means all the B elements must map with the elements of A. And when we will combine both the properties, it should be surjective, it should be injective. Means injective functions with the surjective nature of mapping all the elements of B is our bijective function. So you can see here we have A and B here, okay. I am just showing from the diagram mapping. What are the elements here? We have 1, 2, 3, and here 4, 5, 6, okay. So all the elements of B must have set with the elements of A as well as the injectivity. What was that? All the elements of A have a unique. So when we will see here, F1 is there, okay. What is our output? 4. So 1 is associated with the 4, right? Then we have F2. What we are getting? 5. So 2 is associated with the 5. And F3 is equals to 6. So what you are saying, that all the elements of B are associated with A, but all the elements of A is also associated with the B in the unique manner. 1 have 4, 1 is not associated with the 5, 2 is not associated with the 5, okay. Like what I am saying, that 2 is not associated with the 5, but 2 is not associated with the other elements, okay. That's the function rule. And one, you can see that this is not the case. If you try to understand here, it's not the case, right? If this was the case and all the elements are mapping in the B, then it was surjective. But since it is not the case, our association is here simply related to, so you can say that bijective because both injective and surjective. You can say bijective summation of the properties of injective and surjective, right? What is the property of surjective? Range equals to codomain, and here unique association, okay. So they together making the bijective function. So this is the type of functions. Later on we will see some different types of functions that is important, okay. Okay students, bye.